Okay, so this is going to be the lesson on half-life. The keywords are decay, isotope, and random. There's 3 questions that I'd like you to research on the internet. Scribble down some answers, and then I'm going to go through these answers with you. There's also a challenge there, 3 uses of radioactivity. So press pause, attempt the questions, and then we'll review. Okay, so the first question was name all 3 types of radiation. So these are going to be alpha, beta, and gamma. And as you can see, alpha has got 2 positives there and 2 green neutrals. So it consists of 2 neutrons and 2 protons. And we call that a helium nucleus. And it's quite weak. It's not very penetrating. In fact, it's stopped by paper and skin and things like that. So even though it's a type of radiation, it's not that dangerous because it can't actually get into your skin. Beta, if you can see that, is a minus charge there. It's a fast-moving electron. Electrons are negatively charged. So it's just a single particle. It can actually go through your skin and paper. And it's only blocked by aluminium. So it's got a medium penetrating. And then you've got the big daddy of them all, which is gamma. Gamma is not a particle, it's a wave. And you can see it easily penetrates paper, it goes right through aluminium, and even sometimes right through lead, depending on the strength of gamma, its penetrating strength. So it can be blocked by lead, but it obviously depends on the strength of gamma. But it's very, very dangerous because it's so penetrating. So that was the first question in a bit more depth. The second question to the starter is, what is radioactive decay? Well, it's when unstable nucleus, so in an atom, you've got the electron buzzing around the outside, and then you've got the protons and the neutrons in the middle. We call the middle the nucleus. And when that is unstable, once it starts falling apart, it becomes radioactive. So it's either going to give out alpha or beta particles, okay? If we're dealing with that type of decay. So the nucleus there turns into the nucleus of a new element. So if we've got a large element, it'll turn into a smaller element because it's lost some stuff, okay? It's lost some mass. And you can see there the little diagram. We've got a nucleus of an atom, it doesn't matter which atom, and then it's going to decay with alpha. Well, going back to the previous slide, we know that alpha is 2 neutrons, 2 protons, so it's 4 sort of subatomic particles, if you will. It loses that, he says, I'm free, but now he becomes smaller. So he's a new element, in a sense, you know. He's still radioactive, he's still going to lose some more, but that's the key idea there, okay? At least the level we need to understand for this video. The third question was, what is half-life? Now, half-life is a distinct definition, especially in an exam. This is what you're going to have to remember. For now, we're going to just concentrate on mass, but this word here can be replaced with 2 other, I should say, terms. So the time taken for a radioisotope or an element, the time taken for an element or radioisotope, mass, the time taken for its mass to decay by half. So as we just saw on the previous slide, it's going to lose some stuff over time, and the time it takes to lose half of it, we call its half-life. For example, my mass, let's just say I'm 100 kilograms, and if I went on a diet and I lost 50 kilograms, I'm losing half of my mass. The time it takes me to do that is going to be my half-life, okay? That's going to take a while for me. Probably I'll never get to 50 kilograms, but if I could, it would probably take me at least a year. So my half-life would be at least that time. And these elements work exactly the same, okay? You can see there it starts with 16 particles. After one half-life, it goes to 8 particles. After another half-life, it's going to half again, so 4 particles, and then to 2 to 1. So it halves each time. So it doesn't, so just because it lost 8 the first time, doesn't mean it's got to lose 8 the second time. It loses half of the original. So let's just say my half-life was 1 year, and it takes me 1 year to lose 50 kilograms, because I'm starting at 100 to 50. It's probably going to take me another year then to get to 25 kilograms, because that is half of 50. So that is the half-life. And this definition here, you're going to have to learn for GCSE. The time taken for a radioisotope's mass to decay by half. Again, we'll come across some other terms we can stick in there, but for now, let's just keep it to mass. And then we did a challenge for uses. And again, this comes up now and again in the paper, whereby it'll probably give you a lot of text. But these are the main ones that you need to be aware of for uses. So we've got measuring the thickness of paper. So these paper rolls, they're going to use beta particles for that. Obviously, they need alpha to go through the paper. But again, this is something we'll go through with the exam-style questions. Gamma is used to sterilize medical equipment. Beta is used in smoke alarms. Blood and fluid tracers. So these tracers, if I wanted to find something that's wrong with me, if I got a leaky valve, what I could do is ingest a small bit of radioactive material that's quite safe. It's got a short half-life, and they can actually trace that then with a meter. They can also do it with, if you're looking for a water leak in a road, rather than dig up all the roads, they're just going to add a little bit of radioisotope to the water, and then they can actually scan there where the water is coming out. They can actually see the water underground. Okay. Cancer treatment, they use gamma or beta, and then carbon-14 dating. So to just to date rocks, really. That's how we know how old the Earth is and how old some trees and rocks are. So that was the starter. That's a little bit of introduction to the half-life, and then we're going to start practicing some half-life equations. So here's your key objective for this sort of lesson, is to calculate the half-life of radioisotopes to estimate its decay rate. Your keywords: decay, isotope, and random, because radioactivity is totally a random process. Okay, you can't really predict it, although you can estimate its half-life, but you can never predict when a radioisotope will decay. So the first one, so we're going to calculate an isotope. I'm going to do this one for you. So it says there, this typical question, and let me just minimize my face a minute, just so I can, and let's put that up there. Brilliant. Okay, so the question is, the half-life of radium-226 is 1600 years. Calculate the time taken for the activity to fall to a quarter of its original activity. So we've got a couple of steps here in the success criteria. The first thing we need to do is highlight what we know. So, for example, what is the half-life, number of half-lives, and the activity? Now, I've kind of abbreviated these to half-life is the time it takes, isn't it? Remember I talked about me losing 50 kilograms. What's my half-life? It's going to be probably a year, so it's the time. And you can see in this table down here, I've got my time as a row. So let's just leave that there. We've also got number of half-lives, NHL, like the ice hockey league, okay? I've put that at the top, number of half-lives. So that is, if I wanted to get to 25 kilograms, first I'm going to have to lose 50 kilograms, that's one half-life, and then I'll half that again, 25 kilograms, that's going to be 2 half-lives. So that's the number of half-lives. All this should make sense in a bit. Then we've got activity, mass, or percentage. Now remember I said the definition of half-life is the time it takes for a radioisotope's mass, or activity, or percentage, or we say parent nuclei, okay? But we went with the definition for mass, but that could be either activity, mass, it could be the percentage, it could be a ratio as well. As you can see, we've got a ratio here, we've got 1/4. Okay, so that's why I've got amp there, amp, activity, mass or percentage. Trust me, this will become clear as you see me go through it. So the NHL always starts, so first of all, let's highlight what we know. So I'm just going to get my highlighter out. So I've got 1600 years, and I've got a quarter of its original activity. Don't be fooled with this 226, because that's all that is the mass number of radium. So whenever you see a dash, okay, an element name with a dash and then the number, that's just the mass number. So the mass number here of radium is 226, and it's got nothing to do with the question. All we're interested in is the time. So this is the time by here, and this is your amp, really. This is your activity, mass or percentage. Instead of a percentage, we're using a ratio here, and it's a quarter. I want to see how long it takes Mr. Timothy to get to a quarter of his mass. That's all I'm saying, really. I'm just replacing Mr. Timothy now for this element, radium 226. It's going to take 1,600 years to half once, and then it's going to take another 600 years to half again, and then it's going to take another 600 years to half again. Now, some of you will be onto this straight away and think, oh, that's all I've got to do is times 1600 by 3. Okay? But these questions do get slightly more difficult where you have to work back. And this is where this table here comes in handy. So, back to the success criteria. It says there, your NHL, okay, I'm here now, your NHL starts at 0. And then increases by 1s. And that makes sense, because if we were talking about half-lives, we can either have 1 half-life, 2 half-life, 3 half-life. But at the start, I'm just going to zoom out slightly here so I can write, it's going to start at 0. So I've got 0 half-lives. And then I'm going to have 1 half-life, and then 2, and then 3. So it goes up in 1s, and that never changes. The biggest mistake here that I see is students starting in this column with 1. It's got to start at 0. It also says there, time also starts at 0 and increases by the half-life. Well, what's the half-life? It's the time it takes to half-life. So it's going to start at 0, and then I'm going to actually use my half-life. And my half-life is my time, and my time is 1600. Now, this increases by the same amount every time. So remember I said for me to lose 50 kilograms, it's going to take 1 year. And then for me to lose half of that again, it's going to take another year. Well, that's 2 years in total. Well, the same applies to this, because instead of 1 year now, I've got 1,600 years for 1 half-life. Well, what's 2 half-lives? Well, 2 times 1600 is going to be 3200. I'm cautious to say doubling, because I don't want to use the term doubling, because I am timesing by this number 2. After 3 half-lives, I need to add another 1600 on, because it's the time taken to half each time. So I'm going to add another 1600 onto 3200, and that's going to bring that to 4800. So bearing in mind, these tables will not be given to you in the exam, and I don't know how long I've got to do this. I know for this answer, I only need 3 columns. 3 columns. But sometimes it can go up to 10 half-lives. So when you're drawing these out, just give yourself plenty of room. Now, your amp, your activity, mass, or percentage. This is what this is now, a quarter. It's not a percentage, it's a ratio. And it says here, percentages always start with 100%, because at the start you always got 100% of something. And a fraction will always start with 1 over 1, because 1 over 1 is essentially 100%. So I am going to start, because it's a fraction, I'm going to start with 1 over 1, which is essentially 1, isn't it? Now, what is half? Now, this is where we come into half-life. We're going to start halving it now, because after... Oh, I've put it in the wrong column. You can see now, let me just rub that out. 1 over 1. So at 0 half-lives and after 0 time, we've got the full mass of 1 over 1. But after 1 half-life, it's going to lose half its mass. So what's half of 1? It's a half. Okay? It goes from 1 to half. And that's going to take me 1600 years. Well, what's half of a half? Hopefully you know this from maths. It's a quarter. So, just like I said with Mr. Timothy, I started at 100 kilograms. After 1 half-life, I go to 50 kilograms. That's after 1 half-life. After 2 half-lives now, I'm going to half again, going to 25 kilograms. The same applies here. So I've got, after 1 half-life, I've got half. After 2 half-lives, I've got a quarter. So after 3 half-lives, what's half of a quarter? It's 1/8. And that really, I've gone a bit too far because my question says, what's the activity after a quarter? How long, calculate the time taken for it to fall to a quarter of its original activity. Well, there's your time. It's 3200 years. And that is how you use the table, okay? You could have done that an easier way, I'll admit, but knowing the table will help, I promise, because these questions can get quite complicated. As it stands, this question is quite an easy one. So the answer to this would be 3200. Okay, we're going to try a couple more. So, it says there, the half-life of Radon 222 is 3.8 days. Calculate the time taken for its mass, should be for its mass, to fall from 60 grams to 3.75 grams. So the first thing I'm going to do, I'm going to make myself a table here, okay? Because I can see that I'm not being given a table this time. So I'm just going to zoom out slightly. And I don't know how many columns I'm going to need because I don't know how far I've got to get. So I'm just going to go 1, 2, 3, 4, 5. I'm going to go 5 lines down. I'm going to do my 2 lines across, okay? I'm going to put my NHL at the top, number of half-lives. I'm going to put my time there, and I'm going to put my amp there. Okay, so this is a process that we're going to use all of the time. We're going to draw this table like this: NHL, time, and amp. So even if you haven't got a clue what's going on at the moment, hoping at least you'll be able to do this. And then if we look at our success criteria, it says there the NHL always starts with 0 and the time always starts with 0. So just like we did last time, no matter what we know about the question, we can go 0, 1, 2, 3, 4. The time always starts at 0. I'm not sure of the half-life yet. I haven't looked at the question properly, okay? So I've filled the table in as much as I can without any information. So I guess what is left for me to do now is to highlight what I know. So let's go through the question. So it says there, Radon 222. Now this 222 is just the mass number. Doesn't mean anything to me. Is 3.8 days. This is going to mean something to me. 3.8 days. I'll just highlight that. Calculate the time. So it wants me to find the time again. Taken for its mass to fall from 60 grams to 3.75 grams. So my half-life, the time it takes to decay by a half, the half-life is 3.8 days. So I know now after 1 half-life, it's going to be 3.8 days. What's going to be 2 half-lives? Well, it's going to be 3.8 plus another 3.8. So that is going to be 7.6, I think. 8, yeah, 7.6. Then we need to add another 3.8. So that's going to be 11.4. And then after another 3.8 days, it's going to be 15.2. 15.2. Now, I might have made a mistake there. I haven't got really got time to check. If I've made a mistake, please drop a comment. I have made mistakes before. I think it's right, but could be wrong. But you can see the process, okay? This is why I'd recommend using a calculator in an exam. So after 1 half-life, I've got 3.8 days. After 2 half-lives, it's going to take 7.6. Okay, I keep adding 3.8 each time to get 4 half-lives. And now it leaves me with my activity, mass, or percentage. And the percentage includes that ratio as well. You're never going to get it given anything else, 3 things. A gram is a measurement of mass. So this time we're dealing with mass. Now instead of starting with 100 grams, because when we started with 100% before, or 1/1, we were always dealing with a full amount. But we had no idea how much mass was in that full amount. Well, we do this time because it says it starts at 60 grams. So my full amount there is 60. So right at the start, at 0 half-lives and 0 time, right back where the timeline begins, it is 60 grams. And then we have to half it because it halves each time. So what's half of 60? After 1 half-life, oops, it's going to fall to 30. Be careful now not to take 30 again off because you're going to be left with nothing. Just remember, Mr. Timothy goes from 100 to 50 and then 50 to 25 because he halves again. This is exactly the same. So it goes from 60 to 30. What's half of 30? 15. What's half of 15? It's going to be 7.5. What's half of 7.5? 3.75. Okay, that's where we are. The time it takes for its mass to fall from 60 to 3.75. Just going to highlight now. You can see that question could have asked me how many half-lives it takes as well. This is why this table is so handy. And you can see it's going to take 15.2 days. So 15.2 days, okay, for it to fall from 60 to 3.7. I hope you can see that. We're going to do another one just in case, and then we're going to do some practice. Again, this is a slightly tougher question now. I think we have to work back with this one. So calculate, so after 42 days, let me just zoom in on this. After 42 days, the activity of a sample of phosphorus 32, this 32 is just the mass number of that element, has nothing to do with the question. It's decreased from 400 becquerel to 50 becquerel. Now, becquerel is the unit of measurement for radioactivity. So we're dealing with activity now. When it comes to this amp down by here, it's the A for activity. It drops from 400, which is its starting activity, to 50. Okay, so 400 is its starting, 50 is going to be where we need to see it gets from. What is the half-life of phosphorus? So we don't know what the half-life is this time, but we do know it takes 42 days for that to drop from 400 to 50. Now, you could calculate that if you're clever without this table, but this table does the job for you. So let's just follow the success criteria, and we're going to get maximum marks every time. So highlight what we know. So I'm just going to go through my highlighter. I got 42 days. So that's not my half-life, because it usually says the half-life is 42 days. Here it says after 42 days the activity drops. So it's me like me saying it takes 1 year for Mr. Timothy or it takes 3 years for Mr. Timothy to drop to 12.5 kilograms. Okay, so you don't know the half-life. Okay, we know that it's 50, but it's going to take 3 years to drop from there to there. So this time we've got to be careful not to use that 42 as a half-life. It drops from 400 to 50. So my success criteria. Okay, always start at 0. So I'm going to start at 0 and 0. That's the first thing I can do without even reading the question. And I can go 1, 2, 3, all the way up to 10 if needed. There are questions out there that go all the way up to 10 half-lives. So what's next? So it says start with the reactivity percentage. Okay, so we're going to go to the question now. So after 42 days, so let's go from my becquerel here. I'm going to start now at 400. So at 0 half-lives, I've got 0 time, and it starts with 400 becquerel. That is its maximum, okay? And it needs to drop to 50. So I need to half that each time to get to 50. So what's half of 400? It's 200. What's half of 200? 100. What's half of 100? It is 50. And that is our end result there. So it drops from 400 to 50. Brilliant. But we don't know its half-life, but we do know that it takes 42 days to get to 50. So now it's a case of working backwards. Where before we were going 1 times whatever the half-life is that, 2 times whatever the half-life is that, 3 times whatever the half-life is that. I guess now we can work backwards, and we could say, well, this is 3 half-lives, and you got 42 days. So we need to divide 42 by 3 now, don't we? We need to see how many times 3 goes into 42. And I think that is, without using my calculator, well, I'm going to have to use my calculator for this. It's been such a long time since I've done these. It is 42 divided by 3. Here we are, it's 14. Okay. Sorry, Mr. Woolley, if you're watching this. But, so it's 14. So I'm going to go 1 half-life is 14. That's all I did was a quick calculation there. 3 divided by 42. It gives me the answer of 14. 14. What's 14 plus 14? 28. What's 28 plus 14? It's going to be 42. So you can see our half-life now is 14. That is one of the more difficult ones. With practice that will come. But it's there just to show you. Okay? We've got to try it now. Press pause. I'm just going to zoom in on this question a minute. I'm going to read the question with you. The half-life of protactinium is 234. 234 is 6.5 hours. Calculate the time taken for its activity to fall to an eighth. So we're dealing with a ratio here. Okay. I'm just going to put the success criteria there. And press pause. Off we go. And this is what I had. So I did my table, I put my zeros in, 1, 2, 3, 4. Okay, I didn't know how many we needed. My half-life, it tells me, of that protactinium, that's it, protactinium, isn't it? 6.5 hours. 6.5 plus 6.5 is 13, plus another 6.5 is 19.5, plus another 6.5 is 26. And then it needs to fall to an eighth. So I start with 1 over 1, because I always start with my a full ratio, yeah? And if it was percentage, I'd start with 100%. And then half of a 1 is a half, half of a half is a quarter, half of a quarter is an eighth, half of an eighth is 1/16. I didn't know how long I needed to go for. And then I could see there from the question, how long does it take to get to an eighth? Well, it takes 19.5 hours. Hopefully you've got that. If not, go back and have a look. Or have a look at some other methods on YouTube of how people calculate half-life. But the table is quite rare. So we used to call it the Timo table, okay? The Timothy table, because I didn't invent it, but I saw someone actually do this, not on a video, but work through it. And it's just a method that I've always carried through. You might find it on YouTube, and you might find other methods on YouTube that help you. But I've got to be honest, this one seems to work. I definitely improved the work of the year 11s in previous years. So I would stick with the table. Probably recommend that you go back and watch me go through them again. Okay, but practice makes perfect. Like anything, you don't just learn a language overnight. You've got to put some time into it, and this is one of those processes. You have to dedicate some time, and if you don't get it first time, it just means you have to go and do it again. It doesn't mean that you're thick or you just don't do maths, or I just don't do maths. It just means that you have to put some work in, and that's all it is. Okay, hard work pays off, I promise. So here's your submission, your assignment. So there's 6 questions in total with 3 levels of challenge. So we've got 2 questions that's quite easy, you've got 2 questions that's standard, and you've got 2 questions that are quite challenging. I just want you to choose two questions, so one of those difficulty levels to submit. So choose your difficulty level and submit, no matter what year you're in, no matter what class, okay? You just go for the level that you think you're good at. So you're only submitting 2 answers in this case. That's all we want is 2 answers, okay? You take a photo or you submit, whatever you do, okay? Use the layout that I've shown. So please, please, please use that table. No good just putting the answer down because I cannot see your working. These questions are usually worth 3 to 4 marks. If you just write an answer down and you've done it all in your head, it's going to get you 1 mark. What a waste of marks, considering you know the answer. I need to see the method, just like in maths. So it says there, take a photo and upload it to Teams. Be very clear which questions you are attempting. So sometimes we just, some of the work we've marked, where have I gone? There I am, look. Some of the work we've marked is quite difficult to see where the assignment questions are. You can see that you've gone through the video. It's all good, you know, copying along with the video, but it's quite difficult then to read where the actual questions are. So just be clear, select your difficulty level, be clear, write it, write the question numbers, you know, this is the assignment. You don't need to submit anything else, just the 2 questions is fine. So on 1 piece of paper, bang. You do not, like I just said, you don't need to do the starter or just the assignment questions. So I'm going to go through these now. I'm just going to minimize this. I'm going to go through the questions. So this is your first one. This is level 1. Let me just move this up here. So question 1, level 1. So this is the quite easy ones, okay? So it says that the half-life of radioactive isotope is 27 years. How long will its mass take to fall from 2 grams to 0.25? Question 1. Question 2, on the same level, level 1, isotope has a half-life of 30 years. Estimate how long it will take for the number of nuclei, why is that moving, to decay to 250. And if the starting number is 8,000. Okay, so you've got 8,000 starting, needs to get to 250. Here's your question 3, which is now level 2. Let me zoom in there. Now we're going to go for question 4, which is also level 2. And then these are the challenging ones. So this is your level 3. And then the last question, that should be question 6 there. Okay, brilliant. Good luck, and I look forward to seeing some of these answers.